Imagine sitting in a dark cinema, watching a world so beautiful it almost hurts to look at. A world with glowing forests that pulse with blue light in the darkness, mountains that float in the sky without anything holding them up, and creatures that are 10 feet tall, electric blue, and connected to every living thing around them through something that looks almost exactly like the internet. And you think to yourself, is any of this actually possible? Is there somewhere out in the universe where something like this truly exists? Because the moment that question enters your mind, it refuses to leave. That is exactly what the movie Avatar did to millions of people. And it is exactly the question we are going to answer today. Not by guessing, not by dreaming, but by following real science, real discoveries, and real planets that astronomers have actually found floating out there in the dark. The planet in Avatar was called Pandora, and here is the first thing that will surprise you. It was not orbiting just any made-up star. The filmmakers placed it in the Alpha Centauri system, which is a real place, a real star system, and it is the single closest star system to our own sun, sitting just 437 light-years away from the planet you are sitting on right now. But here is the part that nobody ever talks about. A light year sounds like a unit of time, but it is actually a unit of distance, and 1 light year equals roughly 9.5 trillion kilometers, which means Alpha Centauri is about 40 trillion kilometers from Earth, and if you tried to travel there using the fastest spacecraft humanity has ever built, you would need approximately 70,000 years to arrive, which means you would need to start the journey, then die. And yet, in the grand scale of the universe, that distance is almost embarrassingly small, like walking to your neighbor's house compared to walking around the entire planet. Now, here is where the story stops being fiction and starts becoming something far more unsettling. In 2016, scientists made a discovery that quietly changed everything. They found a real planet orbiting within the Alpha Centauri system, specifically around its smallest star called Proxima Centauri, and they named this planet Proxima Centauri b. It is roughly the same size as Earth. It sits at just the right distance from its star, not too hot, not too cold, sitting in what scientists call the habitable zone, which is the cosmic equivalent of that perfect spot next to a heater where you feel neither too warm nor too cold, just exactly right. And where conditions are just right, liquid water becomes possible, and where liquid water exists, life as we know it is possible. You would think the story ends there, but it does not. Not even close. Because while Proxima Centauri b is fascinating, scientists have found other planets that make the imagination go completely wild. In 2015, NASA's Kepler telescope found a world they immediately nicknamed Earth's Big Brother, and its name is Kepler 452b. This planet is about 60% larger than Earth. It orbits its star in 385 days, which is almost identical to Earth's 365-day year. Its star is almost exactly like our sun in size, temperature, and brightness, which means if you were somehow standing on the surface of Kepler 452b and you looked up at the sky, you would see a sun that looks almost exactly like ours, rising and setting on days that feel eerily familiar. But here is the twist that will stop you cold. Kepler 452b is 1,400 light-years away from Earth, and its gravity is roughly double ours, which means if you weigh 60 kilograms on Earth, you would feel like you weigh 120 kilograms there, and walking across a room would feel like carrying another entire person on your back with every single step. And what happened next in the search for life will completely change the way you see this. In 2017, scientists announced the discovery of the TRAPPIST-1 system, and when the details came through, researchers genuinely sat back in their chairs and stared. This system, about 40 light-years away, contains 7 Earth-sized planets all orbiting the same star, and 3 of those planets sit perfectly within the habitable zone. 3 planets in the same system, all potentially capable of hosting liquid water at the same time. But the detail that truly melts the mind is this. All 7 planets are so close together that if you stood on the surface of one and looked up at the sky, you would not just see stars. You would see the neighboring planets hanging there huge and vivid like enormous moons, close enough to make out their surfaces with the naked eye, and if any of those worlds had civilizations on them, they would have been watching each other across the sky for millions of years. Now you might be asking yourself a question that scientists ask themselves constantly, and that question is this: if these planets could support life, what would that life actually look like? Life on Earth is carbon-based, meaning carbon is the fundamental building block of every living thing on this planet, from bacteria to blue whales to you. But on a different planet, with different chemistry, life might be silicon-based instead, using an entirely different element as its foundation. And silicon-based life would not look, move, breathe, or behave like anything we have ever seen. So alien that we might not even recognize it as life when we first encounter it. And it goes even further than chemistry. The gravity of a planet shapes the bodies of the creatures that live on it. A planet with 5 times Earth's gravity would produce animals that are short, compact, and extraordinarily strong, built low to the ground like living tanks, because anything tall would collapse under its own weight. A planet with very low gravity might produce creatures that are impossibly tall and slender, moving in long, slow, graceful leaps that look almost like swimming through the air. And the color of the star matters too, because plants on a planet orbiting a red dwarf star would not be green. They would likely be red or even black, because they would need to absorb every wavelength of the dimmer, cooler light available to them. And a forest on such a world would look like something from a nightmare or a dream, dark and rustling and alive in ways that would feel completely alien to human eyes. But here is the part that nobody ever talks about. The glowing forests of Pandora are not as fictional as you might think. On Earth, right now, in the deep ocean and in certain forest floors, there are organisms that glow in the dark through a process called bioluminescence. Jellyfish do it. Certain deep-sea fish do it. Some species of mushroom do it, lighting up forest floors with a faint, cool, greenish glow that looks genuinely supernatural. If a planet exists where nights are very long or where very little light reaches the surface, evolution might push life toward bioluminescence on a massive scale, producing exactly the kind of glowing, pulsing, breathtaking world that James Cameron imagined on Pandora, which means the most beautiful thing in that movie might also be the most scientifically plausible. And yet, even if all of this is true, even if Kepler 452b has oceans and TRAPPIST 1e has forests and Proxima Centauri b has something breathing under its surface, we face a problem so enormous it feels almost funny when you say it out loud. We have absolutely no way of getting there. Our fastest spacecraft would take tens of thousands of years to reach even the nearest star, and the planets we are most excited about are hundreds or thousands of light years further than that. But scientists are not giving up. And here is where the story takes a turn that sounds like science fiction, but is actually being funded with real money right now. A project called Breakthrough Starshot is working on spacecraft the size of a postage stamp, driven not by rockets, but by powerful lasers fired from Earth. And the idea is that these tiny craft could be accelerated to 20% of the speed of light, which would get them to Alpha Centauri in roughly 20 years, not 70,000 years. 20 years. The catch is that they would be too small to carry humans, too small to stop when they get there, and they would streak through the target system in a matter of hours, snapping pictures as they go. But even that would be extraordinary, because for the first time in history, we would have actual images taken from another star system, not paintings, not guesses, but photographs. And then there is the concept of wormholes, which are theoretical tunnels through the fabric of space itself. And the idea works like this. Imagine drawing 2 dots on a piece of paper that are far apart, and then folding the paper so the dots touch, and suddenly the distance between them is 0. A wormhole would do that to space, creating a shortcut between 2 points that are billions of kilometers apart, allowing travel that would otherwise take millennia to happen almost instantly. We have never found one. We do not know if they can exist. But the mathematics of general relativity does not rule them out, which means the universe has not yet told us no. Now here is the question that has haunted scientists since 1950. The question that physicist Enrico Fermi asked over lunch one day when the conversation turned to aliens, and the question was devastatingly simple. If the universe is so vast and so old and filled with so many planets where life could exist, then where is everybody? This became known as the Fermi paradox, and it remains one of the greatest unsolved mysteries in all of science. Some scientists believe advanced civilizations are out there but have no interest in contacting us, the same way we do not bother trying to communicate with ant colonies even though we walk past them every day. Some believe alien civilizations are hiding, perhaps because the universe contains dangers we cannot yet perceive, and staying silent is the only safe strategy. Some believe life is so rare, so dependent on an almost impossible chain of coincidences, that we truly are alone, the only voices in an infinite silence. And the most humbling explanation of all is simply this. The universe is 13.8 billion years old. It contains more than 2 trillion galaxies, each holding hundreds of billions of stars. And we have been searching seriously for maybe 70 years, which means we have examined a fraction of a fraction of a fraction of what exists. And concluding we are alone based on that search is like dipping a teaspoon into the Pacific Ocean, finding no fish, and declaring the ocean empty. What Avatar really gave the world was not just a movie. It gave people a feeling. The feeling of looking at an alien world and believing deep in their chest that beauty and strangeness and life might be waiting somewhere out there in the dark. And that feeling turns out to be grounded in something real, because the universe is genuinely full of worlds we have not visited, atmospheres we have not breathed, skies we have not seen, and creatures we cannot yet imagine. And the most honest thing science can tell you today is not that we have found them, but that we have barely begun to look, and the search itself, slow and patient and full of wonder, is perhaps the greatest story our species has ever told itself, one that has no ending yet, and may not for a very long time. But that is exactly why it is worth telling.